Hi everyone! We are going to start looking at basic inequalities. We've talked about inequalities a little bit when we talked about interval notation, but now we're going to specifically just define all the different ways you can use an inequality. An inequality provides a way for an interval with many solutions to be true, so maybe even highlight that. Many solutions are true, instead of just one unique solution. So before we had this idea of looking at an equation and finding one unique solution. In this case, you have many solutions that are true. In this section, we'll look at the way we can convert statements we've used all the time into math notation. So you probably don't realize that you've been using inequalities in your everyday talking language, but we're going to look at examples of ways that you do use those in everyday language and how you can represent those statements to these symbols based on the situation. Let's go ahead and start with the greater than scenario, and I'll go ahead and read the situation here. Once I had a cold calling job for an insurance company, and it was a really bad job, and I only worked for about 6 weeks with the company, but my boss would tell the employees that we all had to meet our cold calling quota. If you're not familiar with cold calling, it's where you have to call people in the phone book and hope that they like your product enough to be interested. If we met a cold calling quota that was more than 12 interested contacts per week, we need to write the cold calling quota as an inequality in as many symbolic ways as possible. So I'm going to go ahead and highlight the critical information here. It says we had to have more than 12 interested contacts per week. So I know that my inequality has to be greater than, and it's always the big side is how you would read it, big side first. So since the big side of the inequality is open, that means this is read as greater than 12 interested contacts. So then the 12 would be there. Now, on a number line, you could also write this as, if this is 0 and let's say this is 12, I just scaled my number line just like that. Greater than is a parenthesis for those of you who remember the notation from previous sections. So I would open the parenthesis to the right, and anything to the right would be true. I could also label this as, I'm going to write another number line. I'm just showing you all the different ways this same wording can be represented on a number line. You could also have an open dot, meaning not including 12, but anything to the right of 12. So that notation is also accurate. And then lastly, interval notation, which we would write as parenthesis 12, comma, infinity, and you never have a bracket on an infinity, so that would be interval notation. Now let's look at another scenario. This is greater than or equal to. So there's a really good chance you guys have seen or heard of a friend who uses a phone for their business responsibilities. Usually you have to have a data plan that will accommodate all the conversations, accessing the internet, etc. So this plan needs to be at least 4 gigabytes of data. Some of you might be thinking that's not enough. Some of you might be thinking that's way too much. But the big idea here is to understand that it is a statement that you need at least 4 gigabytes. So I'm going to highlight that part because that is the critical information that will allow us to write the inequality. Notice that it at least, more than, less than or equal to, those are all words that define the type of inequality you're going to use. So if they don't want to get penalties for data overusage charges, they need at least 4 gigabytes of data. So first I'm going to just write a at least here, so it means that it's greater than or equal to, meaning you could have 4 gigabytes of data, or anything more than that will be okay, but you can't go smaller. And we can write it as 4 gigabytes here. Now we need to write the friend's data usage as an inequality in as many other symbolic ways as possible. So I'm just going to write data plan greater than or equal to 4 gigabytes. And then if I want to write this in interval notation, I will do that after I plot it on a graph. So here, notice I can just throw 0 wherever I want when I create my own number line. And then we'll say this is 4 right here. So anything greater than or equal to 4, so I can use a bracket now. Opening to the right toward infinity. Now, most of you can't. Well, we could get unlimited data. That would be equal to infinity. Now, let's go ahead and try the next notation. You may also see something similar to this, where you have a number line with an open dot at 4. Now, an open dot would not include 4 gigabytes, so we would have to close it to say, yes, we're including 4 as part of the inequality, and that also heads toward the right, toward infinity. Those are the 2 ways you could represent greater than or equal to on a number line. The interval notation for that would be a bracket at 4, so open bracket 4, comma, infinity, close parenthesis. And you might be wondering why I'm saying all the actual technical words for this, and that's just so that it's easier to get used to hearing that in your head when you write these intervals down. Now let's look at less than. So in a less than scenario, here's kind of a general average for if you're trying to look for a healthy fat percentage. An average adult male should try to balance their diet in such a way as to have a body fat percentage less than 20%. Write the body fat percentage as an inequality in as many symbolic ways as possible. So go ahead and pause the video and give this a try on your own and see if you can figure this out. Go ahead and plot the points on a number line. Go ahead and try and highlight where the information states what inequality type this will be. And then see if you can also write this in interval notation. Welcome back. We're going to highlight the inequality statement, which is less than 20%. Now, if you used a decimal for this or just 20, either one is fine, as long as you remember what that number represents, that it is a percentage. I'm going to go ahead and do just a 20 here. So 20% is represented, and I might even just say percentage above it. So I remember that that's what I'm representing with the 20. And then it says less than, which means I could open a parenthesis to the left, and anything less than would be correct. Now, it doesn't make sense to have a negative body fat percentage, but in this statement, let's just keep it simple, less than 20%. Now, let's also really quickly just write this as an inequality. Less than means the smaller side is first, and then the 20. And you could say 20%. Now, remember this is body fat percentage, so I'm going to write this as body fat percentage, BFP. Now, let's go ahead and write another inequality on a number line where we have 20 here to the right, and anything less than that. But this time let's use open dot, close dot. So since it's less than but not equal to, we leave the dot open and then point the arrow to the left. And now for interval notation. We have open parenthesis, negative infinity, comma, 20, close parenthesis. And now the last one we have here is less than or equal to. At some rides at a carnival, there are height restrictions. On a bumper car ride, anyone 42 inches or shorter cannot ride the bumper cars. Write the height restriction for those who cannot ride the bumper cars as an inequality in as many symbolic ways as possible. Well, I'm going to highlight the part where it says what my inequality statement is, which was anyone 42 inches or shorter cannot ride the ride. So I'm going to make a statement, person who cannot ride the ride. So who is too short, and then is less than or equal to 42 inches. Now you might be thinking, why did you write it that way? Remember, we're looking for the person who is too short. So those who cannot ride the bumper cars. That means that they are shorter than or equal to 42 inches. If they go above that notch on the little height restriction measurement, that means that they can ride the ride. And now we're going to write two number lines, one for brackets and parentheses, the other one for open dot, close dot. We'll go ahead and put 42 inches over here on the right of 0. In the first number line, we'll have a bracket opening to the left. So anything to the left is true for somebody too short. And in our second scenario, we'd have a closed dot opening to the, or going to the left, which is also true. Anyone too short would be to the left. Now again, does it really make perfect sense in a real life scenario that the number line goes to negative infinity? No, because we really don't have people that are negative infinity height. So it would technically stop at probably like 18 inches or so. But for this scenario, you understand that we're just trying to introduce this idea of inequalities. One last thing, interval notation for this. Would be open parenthesis, negative infinity, comma, 42, close bracket. All right, we'll look at solving basic inequalities in the next video.